Alright, so part 2 of integration review, that's both AB and BC, and eventually I might do the BC stuff only, but this is for both AB and BC. So today we're going to learn about U sub, and so we're going to do a bit of derivative review. So we know that when we are taking the derivative of a function that isn't just a polynomial or whatever, you have to take the derivative of the outer and multiply it by the derivative of the inner. So we're going to take 3, move it to the front, and then subtract 1 from the exponent, and then not only that, but we have to multiply it by the derivative of this, so it's going to be times 2x. So the final thing would be 3 times x squared minus 4 squared times 2x. Now, if we wanted to integrate this with respect to x, we totally could. And because we just saw this, we would know it's x squared minus 4 cubed. And some people can just like look at it and figure it out. This is just that. But we're going to learn a method of integrating these weird functions, if you will, that will make it slightly easier. So not every integral can be solved like this, but it's a totally doable way to do some integrals that are a bit confusing. So we have an integral on the left, and this is what we call U substitution. Alright, so we know that this is obviously the inner function right here, and this is going to be the derivative of the inner, and this is the outer function is something cubed. So we have to undo this. And so what we can do is we could say that this is some variable. We're going to say let u be this inside function, x squared minus 1. And so differentiating both sides with respect to x, or differentiating both sides, we'd say du is going to be equal to 2x dx. And so we do not have 2 x's over here. We in fact have 1x. So du, that looks like a v, but over 2 is equal to x dx. This might be slightly more slanted. So now if we replaced stuff with u, right, we said that this is u, so this would be u cubed, and the du over 2 takes care of this and this takes care of these things. So we could just write u cubed du over 2. And that is the exact same integral. And so we can just say this is u cubed, the integral, bring the 1/2, and then du. And we can now use our power rule for integration and say u cubed, add 1 to the exponent, so that's u to the 4th, and then divide by that, so that's 4, and then plus c, and then 1/2. But wait, we don't want it in terms of u, we want to substitute it back in for x, right? So we now have, let's just say, this is 1/8, because 1/2 times a quarter is 8. So we have 1/8, where we know it's going to be over 8, so we have, that is not an 8, let's try that again, and third time, 8 x squared minus 1 to the 4th, because this is u and we're raising it to the 4th power, and then we can't forget the plus c, and that is it. Alright, so here we have another problem, and so when you first look at this, I didn't see this cube, and I was about to do this rational function style and just integrate it, right? Like, but no, there's this cube, and so what are we going to set to be u? And if you guys want to try this on your own, you can, but I see that this is probably the inside function. So we're going to set 1 plus square root of x equal to u. We're going to say let u equal that, and we're going to say du is what? 1 plus 1 over square root x over 2 square root x dx is du. Now, we do not have 1 over 2 square root x. We just have 1 square root x on the bottom. So we're going to multiply both sides by 2 to get rid of that. So that's 2 du is equal to 1 over square root x dx. Now we can rewrite this in terms of u. So let's do that. So we have now this integral, and so we said this is u, so we just have u cubed, and but multiplied by 2. So we can pull that 2 up front because it's just a constant coefficient. And the du, it encompasses the 1 over square root x and the dx. So we can just, like before, use our power rule for integration. So this is going to be, add 1 to the exponent, so u cubed is going to be u to the 4th over 4 times 2, which is just going to be over 2, and then plus c. Now, we are not complete. Let's just substitute 1 plus square root x back in for u. So this is going to be 1 plus square root of x, because that was what we said was u. And we're going to raise this to the 4th power, divide it by 2, and then do plus c. And that is it. Alright, here is a u sub problem with some trig. Now, there's a couple of things I could do here. I could say that I know sine squared is cosine squared. Let's see, sine squared plus cosine squared is 1. So it would be 1 minus cosine squared is sine squared. I could do that and try and integrate that. Or I know that sine squared is 1 over cosecant, or sine is 1 over cosecant. So this is the same as saying 1, not 1 over cosecant squared, not s, c s, can I write an s? Cosecant squared of 5x dx. Now, this one isn't as involved as the other one using, like, the x's and stuff. But we're still going to do u sub, just to get in the habit. So, we're going to let u equal the inside function. Which is this. Because it's, and you might be saying, what about this cosecant squared? Well, the integral of cosecant is negative cotangent, because cotangent, the derivative of cotangent is negative cosecant. I'll write that over here. So dx of cotangent is negative c s c squared x. So when I integrate this, we're not having to do two u subs, because this cosecant squared is being encompassed by the when you integrate it, it's cotangent. So we're going to say u is going to be the inside, which is 5x. Du is 5 dx. But we do not have 5 dx's, so we're going to say du over 5 is going to be equal to dx. I'm going to erase this and write a better 5. Du over 5. Alright, so let's rewrite this integral in terms of u. So, CSC squared u du, and then you have 1/5. And so the integral of cosecant squared is going to be cotangent, but negative, because cotangent is negative cosecant squared, or the derivative. So this is going to be negative cotangent, because we're doing cosecant, cotangent u, and then we can't forget over 5, and the plus c. And then substitute 5x back in for u, so that's going to be negative cotangent of 5x over 5, not as a u, let's try that again, 5 plus c. And that is our answer. Alright, so we have this definite integral here, and actually let's just do pi. but we have learned all of the tools needed to do this integral. So, I would like you guys to give it a try, but let's go. So we know that this is the inside of this cosine function, so we're going to do some u sub first. So we're going to let u be x over 2, and du is going to be dx over 2. And we don't have an over 2, so we're going to say du, or 2 du is dx. So now the dx is taken care of, and the u is taken care of, so we can rewrite this as the integral. Oh wait, these bounds. So let's go back over to our u world, right? And so these are x bounds, not u bounds. So let's substitute these into our equation for u, because these are in x terms. So 0 over 2 is going to be 0, right? So 0 is the first bound, and the second one is going to be pi over 2, because we're just substituting it in here, so pi by 2. So now we can actually rewrite this as integral from 0 to pi by 2. Pi by 2 cosine of u du. Now, let's think. What is the integral of cosine? What would give us cosine when we differentiate it? Well, sine. Sine, and then we get to remember the 2. When we differentiate sine, we get cosine. So when we integrate cosine, we get sine. So we're going to be 2 sine u from 0 to 2 pi. Sorry, to pi by 2. And so let's substitute everything. And so so we have 2 times, now what is sine of pi by 2? That is 1, because it is on our little unit circle, right? We have our unit circle, and that is the y-coordinate. And so when this is pi by 2, and so the y-coordinate here is 1. So this is 1. So this is 1. 2 times 1 minus sine 0. Sine 0 is 0, because if we look at the unit circle, it is the y-coordinate, and there is no y value there. So 2 times 1 minus 0, or 2. Now let's do one more to prove we got this. Alright, so how would we go about integrating this equation? So it doesn't look like this is a u sub, because it is a rational function. So we could rewrite this as the integral from 1 to 9 of 9x over square root x minus 3 over square root x dx. And let's use properties of exponents to rewrite this again. So this is 9x to the 1/2, or yeah, 9x. Let's actually, we're gonna toss this 9. No 9s. Alright, so we're going to do, this is x to the first over x to the 1/2, and so this is just 1 minus 1/2, or x to the 1/2. Alright, and then we are subtracting 3, and then there's 0 x's here, so that's just going to be 3x to the negative half dx. And now we can use our lovely power rule for integration. Add 1 to the exponent and divide by that exponent. So that's going to be over 3 over 2. And this is going to be divided by it'll be divided by 1/2. So dividing by 1/2 is the same thing as multiplying by 2. So now let's rewrite this. So that would be 2 this is 2/3, because I divided it wrong. So this is 2/3 so 2/3 x to the 3/2 minus 6x to the 1/2 from 1 to 9. And so now we can start shoving numbers in. Right, so 2/3 to the, okay, x to the 3/2, or 9 to the 3/2, 9 to the 3/2, yeah, let's just write everything out, because, and then x is 9 in this case, so that's going to be 9 to the 3/2 minus 6 times 9 to the 3/2. No, that is 2. Over 2. And so this is our 9s. And then we're going to shove in our 1s now. So 2/3 times anything, or 2/3 times 1 is 2/3. 2/3 times 1 is 2/3 minus 6 times 1. So 6. And so when you simplify this out, see here, 9 cubed is, okay, let's see, the square root of 9 is 3. 3 squared is 27, or 3 cubed is 27. 27 times 2 over 3 is 18, minus 9 squared. Oh, this isn't to the 3/2, this is to the 1/2. Not, okay. It's 1/2. 9 to the 1/2 square root of 9 is 3. 3 times 6 is 18. So that's going to be 0 plus 2/3 minus. That should be 16 over 3. And that is it.